All right, 3. So p varies inversely with x. If p equals 7 when x equals 8, find the value of p when x equals 7. Now, you just have to remember what inverse means. And inverse means, when you have an inverse relationship, it means that the x and y values, when they multiply to each other, have to equal some constant k. Now, in this case, what you were given was the p value when x is 8. So what you're really getting is you're saying that p is the y value. It's the effect of what x is doing, right? It's the dependent variable. And so what we're really doing here is we're saying that when x is 8, p is 7. So it looks like our k is actually going to be 56. Okay, so k equals 56. Now, when you want to find the value of p when x is 7, well, what you're asking then is what value of p would give me 56 when we've already really figured that out. So the answer is A. So it's a very tricky question if you forgot what inverse is, because inverse relationship, sometimes people think that it's the reciprocal. And so what will happen is that, some people will just choose like 1 because they inverted it somehow, or they just took 8 and made the reciprocal of 1 over 8 for that point, 125. All right. All right, so for 4, what is the domain of the function? Now the domain of the function is, whenever you have a quadratic, your domain would have been all real numbers, okay? But now you have a rational expression, okay? Well, a rational function. And so what this means then is that we have a problem with the denominator, and only the denominator, okay? So let's see what we got here. We've got, we're going to go ahead and focus on this part over right here. We're going to factor 6, and it looks like we would have, what is that, -5, -1. Okay. Now, I actually don't care about the numerator, because that's not going to cause a problem. I can be 0 in the numerator. I just cannot be 0 in the denominator. So this means all of my real numbers are going to have problems. They're going to have issues at these two values that will give me 0. And so what we say, okay, is that 5 would produce 0 and 1 would produce 0. Now, if it was just the denominator and we were trying to solve something, then we would be done. But because we want the domain, we want to find out what it can't be, because it can be everything else. And so our domain is all real numbers except x cannot equal those two. Okay, so this means x can be everything except x cannot equal 5 or 1. Okay, and if you would have just said that would have been, that's pretty sufficient. If you remember the x in the bar and remember the squiggly brackets, that's even fancier. Okay, but that is a perfectly suitable answer. In fact, you could have said all real numbers that x cannot equal 5 or 1. That's fine too. Okay. All right.